So thanks everyone for being here today. I'm really pleased to speak to you about the AI-enabled modeling integration flagship. It's actually being led by four of us, by myself from Texas Advanced Computing Center, where I specialize in developing and implementing intelligent decision support systems. Clint Dawson, who is part of the Odin Institute and a faculty member for aerospace engineering at UT, and he does coastal surge modeling and looks at extreme conditions. Katie Brown, who works in integrative biology and looks at tropical disease spread. And then Francisco Guajardo, who is the executive director for the Museum of South Texas and an integral partner to our project. We've been funded by multiple organizations and agencies in the past few years leading up to this particular flagship. And we're building on top of long-term efforts by many, many people. This team today is trying to extend what's been built previously, but we aren't starting from zero. We're definitely building on the core program from Planet Texas, as well as advances from other funding sources. So the next slide. When you think about how people look at these wicked problems that are the kinds of problems that Planet Texas is taking on, they are typically combinatorial and NP hard, so they're extremely large solution spaces. And when you think then about how are we actually leveraging the computing power of our nation to be able to actually advance our understanding and leverage our ability to simulate and model those problems and then bring them back to the groups that need to use that output and that knowledge for decision making. You can see that on the left-hand side of the screen in the blue, most of the advanced computing applications that you see today are on the far end of a subject matter expertise scale. So the types of users that you see are subject matter experts, modelers, data scientists, and very technical and analytical kinds of researchers. And it is principally researchers in the national supercomputing infrastructure for academia. And TAC is one of those principal centers in the United States. What you see too in terms of the value add that these kinds of activities bring to a decision-making experience is the value increases with every step you move towards taking highly technical information to highly specific information for a particular decision that's at a high level for a decision maker. And so when you think about what's the span of available problems that we could address there, the area for application of advanced computing only expands rapidly and grows, exponentially, basically, or factorially. And so what you see is we're emphasizing applications frequently that are on that subject matter expert scale, but the problems that society is dealing with is on the far end of that spectrum out towards the decision maker, where they need very specific metrics and indicators to help them make data relevant for their decisions. So this particular project is looking at community use cases and how we can improve our ability to leverage computing to actually apply it to community relevant problems. So to the next slide. The AIM project overall is looking to support deep relational and action-oriented work. So we don't want to strictly look at quantitative measures of an observable phenomena from the very traditional epistemology of logical positivism. We're trying to actually think about how do communities experience and live through impacts such as hurricanes or other extreme events as a use case. We want to leverage upon our prior work in intelligent decision support and all of the available tools and techniques that have been developed over generations and many decades in advanced computing. We want to establish reproducible and reusable methods so that what we do in our case study, which is in the Rio Grande Valley, can be moved to other parts of both Texas and other parts of the world. And we also want to do flex testing and evaluation along the way. We want to understand what really works in a meaningful way from a human-computer interaction perspective. And we want to, of course, as all the Bridging Barriers programs are trying to do, we want to accelerate this for transdisciplinary research. Next slide. So in previous presentations, we've shown that we were able to actually build a core infrastructure, a cyber ecosystem for Planet Texas that allowed us to actually take data from the field and push it into a data portal. And from the data portal, we were able to then move it into a model integration platform where we were able to rapidly model flood impacts. And we were able to then push it out into exciting technologies and modalities like augmented reality sand tables, mixed reality headsets, and more three-dimensional kinds of representations on natural user faces and screens. Next slide. So we're going to be building on those capabilities, the core capabilities for the infrastructure of Planet Texas form the anchor points for what we're going to be building and expanding on. So again, I went through, we've got data streaming and ways to get data into the system, the portal, the advanced computing underneath, the integrated model integration platform, and then also we've got a large archiving system so that you can archive large collections of information, bigger than you can do in most library systems because we're leveraging the advanced computing storage capabilities. Next slide. All right, so if this is what the original core cyber ecosystem looks like, let's move to the next slide and I'll show you what the new advanced cyber ecosystem will include. So for this project, we're actually looking at three main approaches and implementations. So on the far left-hand side, we're looking at sites and stories, which is partially funded by another new NSF program. So our build out will be funded by NSF, but this program is going to be able to test and utilize that application. And it's an interactive knowledge capture application that will allow people in the field to actually go into the field and collect annotated information, label that information from what stakeholders and citizens tell them about experiences. We'll use natural user interfaces. We'll be able to co-design inputs with people from the field, and we'll be able to start to understand those lived experiences. It's going to include automated natural language processing. It will hopefully include voice capture, but it will definitely include a table that people can go in and they can draw on a map and we can capture what they draw. They can describe what they're annotating on that map so that we have a record of it. And then we can take that information that they provide us with and we can actually use that as a new citizen generated data file that can inform our modeling approaches. The Science Knowledge Platform is a model integration platform, and that's where the key AI is happening right now. It's semantically enabled. It connects data and models automatically through verbose labels, but also a very set, structured approach for registering models and data together so that you can automate as a recommendation system. What's the problem you have today? I want to look at floods. Great. We have 12 models that are available to you that can adapt and look at floods for you. This will make it easier for people to run models, explore how to fuse data from different models together, look at geoservices, geospatial web services with very large data sets, and actually now put those up on a web service so you can see the maps and then overlay it with new information from the modeled information. And then large scale model encapsulation. That's one of the things that we're working on with Clint's group to try and figure out how to encapsulate his exceedingly large models and simulations. And then finally, we want to look at socio-technical co-design in the end of our pipe. We're not to this part of our project yet, but it's where we're going to try and come back to people again and go out into the field and work with people to understand, did we get the information right? Do the scenarios that we've evaluated make sense to them? Is it helpful? What can we bring back to the modelers so we can reinform the methods and approaches that they're using? Next slide. So as a case study, we're focusing on the Rio Grande Valley, and more particularly, we've decided to look at a past historic event, which is the Hurricane Beulah, which was a major hurricane in 1967, in September, in fact. It was a Category 3 hurricane. It made landfall almost 55 years ago. There were 58 fatalities, and 15 of those fatalities were in Texas. There were $217 million in damages, and there were high winds of up to 160 miles per hour, although most of them near the coast, it looks like ranged from 90 to about 130 miles per hour. What was interesting about this, there were many things that were interesting, but one of the things that was interesting is there were almost 115 tornadoes that were produced by this event. And it was a devastating storm surge along the Texas coast, as high as 15 to 20 feet. Now, what's interesting about all of this is that there are still many, many people that this was a formative event for them in their lifetime, and they still remember it and are happy to talk about what it meant, what it felt like, what they experienced because of this event. Next slide. So what our team is going to do is start with the Museum of South Texas. They have an extensive collection of multiple forms of data and information. They've got oral histories, they've got collected, they've got photographs, they've got a large set of information that we can begin with. And we're going to take those data sets, and we're going to especially begin with photos of where the flooding occurred. And we're going to ask people to help us via citizen science input, ask them to annotate for us if they recognize where a photo came from, if they could annotate it on our map, tell us where it came from, tell us what they know about that place, and tell us what they remember about the event at that time. In addition, we're going to ask them to give us stories of their own lives and mark for us places of relevance for them on this application. So that's going to be the Sites and Stories application. And then in the next slide, I'm going to talk a bit about the hurricane modeling. And Francisco Guajardo, by the way, is leading this one. Next slide. So Clint Dawson is leading the model integration for coastal surge, and he's already completed one model run for an analogous storm to the original Hurricane Beulah event. We didn't have the modeling and simulation tools that were available, nor did we have the data collection that we've got today when Beulah hit. So Clint had to go back in time and create a scenario that was similar to, or Beulah-like, to run an AdCirc model to represent what that coastal surge modeling would have looked like with the best tools we've got today. And then we want to go back now with the photos from the museum and the oral stories from the citizens and try to match those together so we can bring more data back to Clint's model, because we can't get data from the old event. So the only source of information comes from people. And so we're going to take that information and try and georeference it, place it on a map so that we can compare it with what Clint's current model says, and then see if we can adjust the model to improve upon it so it better represents the Beulah event overall. So this is one of our first data products of research, and we're pretty excited about it. Next slide. After an event happens, this is just me showing you that we're going to do that cycle. We're going to take the photos, georeference them, connect them to the model, rerun the model, and inform the model from what citizens know. And so then now we can go to the next slide, which is to think a little bit about after an event happens. Dr. Katie Brown is going to work or is already working on how does that have implications for disease spread post-event. And she's already moved forward there. So for example, if you've got long-term standing water in locations, it's not hard for any of us to realize that that means mosquito-borne diseases are going to be more prevalent, and that you're going to have people exposed to chemicals or possibly septic or other water quality contaminants that are a problem in the area. And so Katie has started to look at both global approaches to actually mapping out what are the risks and what are the likelihoods of spread for emerging tropical diseases. And then she's used the model integration platform from our original core services to start to look at how impacts of that soil moisture can be represented inside her models as well. And then finally, she's looking at how do you start to correlate poverty in Texas with the potential crop losses or spread of tropical diseases that are less well understood. And she's already made severe or significant progress. Severe sounds negative. It's very positive progress. So next slide. So what's next? The next thing in our project, now that we're starting to produce some data sets and beginning to form collections, is we want to actually pull these collections together and get ready to develop a fully well-described collection for Hurricane Beulah that will be completed at the end of our project, but we want to start to formulate it now using these initial projects. And those will go into another core service, the Dolce service for long-term large collection archives. And then also we've got our next socio-technical step, which is to go into the community and interact with that community, the community in the Rio Grande Valley, to understand what people recall from their own experiences and what they can share and bring to us so that we can learn from them. Next slide. So how can you get involved? There are a couple of things that are going to be happening. We've got a Sunday speaker series planned at the Museum of South Texas. There's going to be one event on July 18th, another on July 25th, and a third on August 1st. Each of our team members will be participating in this, and it should be a lot of fun because we're bringing together community members from the Rio Grande Valley for each of these different panel discussions and presentations. I'm also really excited to let you know that Microsoft Azure has joined us and they're going to be supporting work on intersectionality through this Sunday speaker series. And if you are interested in learning about how you can attend, please email and reach out to Jonathan Lowell, who's on this call today or on this presentation today. Thanks, Jonathan. Next slide. And then there's one more way that you can get involved immediately, which is in August, the 9th through the 13th, we will offer another hands-on training for participants who want to use the Planet Texas cyber infrastructure and ecosystem. We did it last year with the core tools. This year, we're going to improve those core tools. We're going to add in what we can from this particular flagship and other flagships that may want to contribute. And we're also going to offer access to some of the Azure tools that Microsoft has made possible for us through the Planet Texas 2050 gift that they've provided. And with that, you can also reach out to Jonathan. And with that, I'd like to say thank you. And I will turn it back over to our hosts.